So when I'm saying to oppose the speed, and now I am saying to oppose the velocity. The reason is electrons, they always move in a particular direction. एका particular direction मध्येच they move in a direction opposite to the applied electric field. In fact, whenever we apply the potential means we apply the force. And there is a formula that F is equal to charge into electric field. And this charge will be electron into electric field. And electric field is given by potential upon length of that conductor. It is given by potential upon the length of the conductor. So if the direction of the force is in this direction, then electrons will be moving in an opposite direction. Electrons will be moving in opposite direction. That is why whenever we talk about the cell, I told you yesterday, when we are having a cell, okay, and when a wire is connected to this cell, and if we have some bulb or something here, if we are having a bulb or anything, any device, maybe tube light, maybe a charger, whatever, the electrons will be moving in this direction. या direction मध्ये electrons जातील. Electrons जे direction आहे ते negative terminal पासून, smaller terminal is negative, bigger is positive. तर electrons ही अशी move करतात. Electrons will be moving like this. आणि जो कन्व्हेन्शनल करंट असतो, ज्या करंट बद्दल आपण बोलतो त्याला म्हणतात कन्व्हेन्शनल करंट, तो ऑलवेज अपोजिट असतो त्या इलेक्ट्रॉनच्या डायरेक्शन मध्ये. इट इज ऑलवेज अपोजिट टू द डायरेक्शन ऑफ द इलेक्ट्रॉन्स. ओके, सो करंट विल be from positive terminal to negative terminal, and electrons will be moving from negative terminal to positive terminal. Remember this. This is because of the nature of the charge possessed by the electron. Electron he negatively charged आहेत, therefore they will be moving opposite to the applied force. Potential लावलं म्हणजेच force आहे. ते कसं आहे that we will be studying later on. हळूहळू मी सगळं तुम्हाला सांगेल. I'll tell you everything. Okay. Now, when I told you about resistance is given by V upon I, and I also told you this is measured in volt, this is measured in ampere, and this is measured in ohm. So therefore 1 ohm is 1 volt per ampere. Now they can ask you objective question. येथे कसा objective question तुम्हाला विचारला जाऊ शकतो? रोहित, वैभव, everybody keep your camera on. Everybody keep your camera on. कसा प्रश्न विचारू शकतात? So I'll tell you that. प्रश्न कसा असू शकतो?
कसा?
Just a minute, I'll tell you, I'm telling you. Now, the SI unit of resistance.
काय?
अरे, परत जर अनवॉन्टेड आवाज आला तर बाळा मीटिंग मधून काढल्या जाईल. The SI unit of resistance is option A, ohm, volt per ampere. Volt per ampere. Sometimes this can also be written as volt per ampere, like this. This is one option. You can have option B, ohm, ampere per volt. Option C, per ohm, volt per ampere. And you can have option D, ohm, ampere square upon volt, something like this. जी इनकरेक्ट ऑप्शन्स असतात तीन, ती काहीही असू शकतात. करेक्ट ऑप्शन एक पाहिजे आणि हे ते ऑप्शन आहे. आपल्याला माहितीये ओहम पण आहे आणि वोल्ट पर एम्पियर पण आहे. ओहम सुद्धा आहे आणि वोल्ट पर एम्पियर पण आहे. सो दिस टेक, म्हणून आपण जेव्हाही एखादा टॉपिक शिकतो त्याचं बेसिक नीट माहिती पाहिजे, त्याच्यावर क्वेश्चन फ्रेम होणार आहे. ओके, इट विल बी ओहम अँड वोल्ट पर एम्पियर. हे पण नाही, बाकीच्या तिन्हीचा विचारच नाही, कारण आपल्याला त्याचा करेक्ट आन्सर माहिती आहे आणि ते ऑप्शन कुठे आहे. सो इट कॅन बी आयदर ए और बी और सी और डी, कुठेही चारी पैकी एका ठिकाणी ते असेल. इट विल बी ॲट वन प्लेस, आयदर ॲट ए और बी और सी और डी. ओके, देन coming back to the topic that we were discussing yesterday, that is the dependence of resistance. And while studying yesterday or while teaching, I told you, Shravani, tired? So I told you resistance depends upon length of the conductor. Resistance depends upon area of the conductor. Resistance depends upon nature of the material. And the dependence also, I told you that resistance is directly proportional to L. It is inversely proportional to area of cross section. It is inversely proportional to area of cross section, and it depends upon the nature of the material. And I told you this is known as resistivity. This is known as resistivity. there is one more factor on which resistance depends, and that factor is temperature. That factor is temperature, and resistance is directly proportional to the temperature. Resistance is directly proportional to the temperature. This also I will explain you. You have to write along with me. हे सगळं मी जे लिहितो तुम्ही व्हिडिओ बघितल्यासारखा व्हिडिओ बघून काही होणार नाही. You have to write with me. Okay. Now, listen here. Suppose I have a conductor. Suppose I have a conductor and there are millions of electrons in this conductor. So we will not consider millions, we will consider only few. So suppose I have few electrons. ही जी electrons असतात, these electrons when they are in a conductor, they move in any direction. They may move this. Suppose if I consider only this electron, this is the negative sign, that means it is an electron. This sign is for showing the charge, nature of the charge. So this electron may move in this direction. When it is moving in this direction, then it will collide. याच्या सोबत तो collide करेल, strike करेल, त्याच्यावर जाऊन आदळेल. It will collide with that electron. Then its direction will change. तो मग नंतर असा जाऊ शकेल. So it will be colliding with this electron. It may go this way. Again it will collide with this. From here it may go this way, or it may come to this side. It will move in any direction, and therefore it is known as a random direction or random motion. The motion of the electron is known as random motion. ज्याला कोणतंही प्रॉपर किंवा फिक्स डायरेक्शन नाही. Okay. Now what we will consider, suppose याला या ठिकाणापासून means from this, for this electron to move from here up till here, suppose it is taking 1 second. असा आपण विचार करूया. Just assume it. Okay. What happens when we increase the temperature? When we increase the temperature, see, when the electron is moving, that means it has kinetic energy. When the electron is moving, it is having kinetic energy. And that kinetic energy is given by half mv square. हा kinetic energy चा आपला formula आहे. So when the electron is moving, and suppose at some temperature, at room temperature, त्याला 1 second लागतोय. When we increase this temperature, it will take, what happens because of that temperature? When the temperature increases, its velocity increases. Its velocity is increasing. And since the velocity is increasing, therefore, it will take less time, maybe it will take only half a second. Maybe it will take half second. That means it will be facing more collisions. Example सांगतो, सपोज आपली एखादी कार आहे, एखाद्या रोडवर चालली. Suppose we have a car, and when this car is moving on a road, and if suppose our speed is 60 kilometer per hour, 60 kilometer, that means it will move 1 kilometer in 1 minute. तो जर स्पीड 120 चा केला तर 1 किलोमीटरचं अंतर कव्हर करण्यासाठी ओनली हाफ ऑफ द मिनिट लागेल. सो यू विल रिक्वायर 30 सेकंड. पण त्या केस मध्ये देयर इज अ पॉसिबिलिटी दॅट some other vehicles or some other obstacles or objects or bodies or whatever, they will come in the path more rapidly. म्हणजे जास्त आपण जास्तीत जास्त लोकांच्या जवळ जाणार आहे कारण आपला स्पीड जास्त आहे, म्हणून आपल्याला ब्रेक जास्त मारावे लागतात. तर लेस, more velocity, less time, and therefore more collisions. More velocity, less time, therefore more collisions, therefore resistance more. त्याचे जेवढे जास्त collisions त्या इलेक्ट्रॉनचे तेवढं जास्त resistance, and number of collisions will increase with increase in time. जसं टेम्परेचर वाढेल तशी वेलॉसिटी वाढते म्हणून डिस्टन्स कव्हर करण्याकरता कमी वेळ लागतो म्हणून जास्त कोलिजन्स होतात म्हणजे जास्त रेजिस्टन्स आहे. ओके, दॅट इज द डिपेंडन्स ऑफ रेजिस्टन्स ऑन टेम्परेचर, and that's why we say that with increase in temperature resistance increases. Jyoti Gaikwad, keep your camera on. Okay, so this was first factor. Now again we'll go back to this. So when I am having some conductor, suppose माझ्याकडे एक असा कंडक्टर आहे. You have to understand the basics, and that's why I'm trying to tell you what exactly happens. आणि याच्यावर ऑब्जेक्टिव्ह क्वेश्चन्स एंट्रन्स मध्ये आहेत. There are objective questions on this in either NEET or JEE. You need to understand this. Suppose माझा हा एक कंडक्टर आहे, याचा एरिया ऑफ क्रॉस सेक्शन A1 आहे, म्हणजेच हा पण एरिया ऑफ क्रॉस सेक्शन विल बी A1. The length of this conductor is, let's say, L, or I will consider L1. Length of this conductor. Now what I am doing, I am applying some force on this side as well as on this side, and I am stretching that conductor. जर मी त्या कंडक्टरला स्ट्रेच केलं तर काय होईल? Tell me, what will happen? What will happen if I stretch this conductor? The length of the conductor will increase. जर मी त्याला फोर्स लावला, खूप फोर्स लावला सपोज, तर त्या कंडक्टरची लेंथ काय होईल? लेंथ इन्क्रीज होईल की नाही? Yes or no? Okay. Now, if the length is increasing, the area will decrease. If the length is increasing, area will decrease. So this area This area is, let's say, A2, and length is L2. Length is L2. Am I changing the material? जर सपोज हे कॉपर असेल तर हे पण कॉपरच ठेवलंय मी. आय एम कीपिंग सेम मटेरियल. सेम मटेरियल असल्यामुळे रेझिस्टिव्हिटी is not changing. Material same ठेवलं, that is nature of the material is same. That means resistivity is not changing. So if the resistance of this material is R1, then it will be rho into L1 upon A1. L1 upon A1. And if the resistance of this is R2, then rho will remain same. Material is not changed. Material is not changed. Length is changing. Area of cross section is changing. Area of cross section is changing. Okay, and therefore if I take R1 upon R2, if I take R1 upon R2, it will be rho into L1 upon A1 whole divided by rho into L2 divided by A2. This rho will get cancelled. This will be, now I will tell you how to write directly. I will tell you how to write directly. Resistance kasa proportional ahe? Directly proportional to length. Resistance kasa proportional ahe? Directly proportional to length. So if I am having R1, then length is directly proportional. So it will be L1 upon L2. तसाही जरी तुम्ही विचार केला, this A1 will come to the denominator and A2 will go to the numerator. That means it will be A2 upon A1. I'll write it once more. परत एकदा दाखवतोय तुम्हाला. R1 upon R2. R1 कशाशी डायरेक्टली प्रोपोर्शनल आहे? L1 शी. R2 कशाशी डायरेक्टली प्रोपोर्शनल आहे? R2 is in denominator, so L2 will be in denominator. R1 is in numerator, therefore L1 will be in numerator because they are directly proportional. They are directly proportional. Into, जसं R1 is inversely proportional to area, so R1 is in numerator, therefore A1 will be in denominator. A1 will be in denominator because R1 is in numerator. R2 is in denominator, therefore A2 will be in numerator. That is how you get it. So thus you get R1 upon R2 as L1 upon L2 into A2 upon A1. This is very important formula where you are having directly questions in 11th standard about this, and some questions in CET or NEET are already asked on this. So we can write down that. Okay, now we will proceed further. We will proceed further. I will draw one more diagram for you. परत एकदा काढूया. This was your conductor. This was the conductor. What is the shape of this conductor? What is the area? It is circular. And area of a circle is how much? What is the area of a circle? It is area of a circle. Vaibhav, Ahire. Area of a circle is given by Sarthak. Area of the सार्थक आईस्क्रीम खात त्याच्यासाठी कॅमेरा ऑन करायला लावला सार्थक. क्लास मध्ये जर आपण ऑफलाईनला क्लास आलो तर आईस्क्रीम घेऊन जाऊ शकतो का? बसायचं नसेल तर सोडून दे मीटिंग. You can very well leave it. No nonsense in the class. Area of the circle is pi r square. Okay. Therefore, same formula. Now, what will be the area? That is, what will be A1? A1 will be pi r1 square. What will be A2? A2 will be pi r2 square. So now from this formula, again I can write, I will write R1 upon R2 is equal to L1 upon L2 into A2 is pi R2 square upon A1 is pi R1 square. We cancel this. So again the formula will become L1 upon L2 into R2 square upon R1 square. That's the formula. R2 square upon R1 square. So this is one more formula. R1 upon R2 is also equal to into R2 square by R1 square. R2 square. Jyoti, keep your camera on. Jyoti Gaikwad. So this is one more formula. Now you tell me one thing. Come to this diagram again. Come to this diagram. You tell me, even if a force is means even after applying the force, even after applying the force, what will remain same? Resistivity is remaining same. Okay, this is one quantity which is remaining same. There is one more quantity which remains same, and that is volume. Volume, you know that when the wire is stretched or compressed, wire जर स्ट्रेच केली किंवा कॉम्प्रेस केली तर व्हॉल्यूम बदलत नाही. जसं आपण एखाद्या बकेट मध्ये 10 लिटर पाणी आहे, पण नंतर ते आपण जर 10 मग मध्ये टाकलं, प्रत्येक मग ची सपोज कॅपॅसिटी 1 लिटर असेल, तर व्हॉल्यूम बदलणार नाही. This type of questions you had in mensuration. If suppose you are having a bucket whose volume is 10 liter and same water you are putting in 10 mugs or in 10 some other containers having capacity 1 liter, so volume will not change. So when the wire is stretched or compressed, volume doesn't change. volume doesn't change. Okay, what is the shape of this conductor? The conductor shape काय आहे? It is a cylinder. It is a cylinder. What is the volume of a cylinder? Volume of a cylinder is pi r square h. Here h will be L. So pi r square L. And for the first conductor, so therefore, if the volume of the first conductor is V1, it will be pi R1 square pi R1 square into L1. And volume of the second conductor will also be, instead of considering V1, I'll consider V only. Both will be having same volume. Both will be having same volume. So it will be V is equal to pi R2 square into L2. Volume remains unchanged. It remains unaltered. It will not change even if we stretch that conductor or we compress and contract that conductor. So volume remains same. Volume remains same. Okay. Volume will remain same. Is it clear to you? That means what I will get? What I will get? I will get, therefore, pi R1 square into L1. So as volumes are remaining same. Therefore, what will get? Pi R1 square L1 will also be equal to pi R2 square L2. Here again this pi will get cancelled. If I bring this L2 to this side, and this R1 to this side, what I will get? I will get L1 upon L2 as R2 square upon R1 square. That means wherever I will get L1 upon L2, I can write R2 square upon R1 square. Now this L1 up, this I will transfer here. I'm transferring it here. That means I am replacing this L1 by L2 by R2 square by R1 square. I'm replacing it. So I will get, from here again, I will get, what I will get here, it will be R1 upon R2 is equal to R2 square upon R1 square into, this is already there. It is R2 square, it is R2 square upon R1 square. So this is R2 square, this is R2 square. So it will be R2 raised to 4 and this will be R1 raised to 4, which I can write R2 upon R1 raised to 4. That means Pranali Patel, Dipali Tambe, Durva Khade, keep your camera on. That means R1 upon R2. This is again important. This is one more formula. This is one more formula. All these formulas you should know. You have to know these formulae. So this is the formula. Okay, this is in the form of R1, R2. But it is only in the form of radius. R1 upon R2. This is resistance. Capital R and capital R1, R2, they are resistances. So only when radius is given, this is in the form of radius, area of cross section we are having, then it is in the form of radius. As well as, now what I know, see here, I know this R2 upon R1, R2 square upon R1 square. Look at this. I know R2 square upon R1 square. That can also be replaced by, L2 by L1 by L2. So I am having R1 upon R2, which is L1 upon L2 into R2 square by R1 square. This now I can replace by L1 upon L2. So my formula will therefore become R1 by R2 is equal to L1 by L2 into again L1 by L2, which will finally become L1 square upon L2 square, which we can write further as L1 by L to the whole square. असं आपण याला लिहू शकतो. So we have one more formula therefore, that is R1 upon R2 as L1 upon L2 whole square. This is the formula when only length is given, when only change in length is given. Change in length. This is the formula. This is the formula when only change in area is given. When only change in area is given, and the above formulae, above this formula is when change in length and area of cross section is given. So now I will summarize the formulae. I am writing all the formulae in a sequence. I will write them in a sequence. R1 upon R2. First it is L1 upon L2 into A2 upon A1. Then it is L1 upon L2 into R2 square by R1 square. Then it is R2 upon R1 whole raised to 4. and last is L1 upon L2 the whole square. These are 4 different formulae for finding the change in resistance. कमीत कमी या 4 फॉर्म्युलावर आणि रेझिस्टन्स वर वेगळे वेगळे 10 प्रश्न सेट होतील. We can set 10 different objective questions on this. 10 different objective questions on this can be set. Okay. Did you understand all these formulae? कोणाला जर डाऊट असेल तर आताच विचारा. Ask it. Ask it. विचारून घ्या. किती टक्के समजलं आतापर्यंत शिकवलेलं ते पाठवा. Come on, send in your chat box. लवकर लवकर पाठवा. इमिडिएटली काही सेकंदामध्ये जेवढे टक्के समजलं सेंड इट इन पर्सेंटेज. पर्सेंटेज मध्ये पाठवा. तुम्हाला जे समजलं तेवढं. लक्षात ठेवा बाळा, तुम्ही आता 11वीत एंट्री करणार आहेत. आयुष्याची ही 2च वर्ष, फक्त 2 वर्ष तुमचं पुढचं संपूर्ण आयुष्य शेवटच्या क्षणापर्यंतच डिसाइड करणार आहे. आज 12वीचा जो रिझल्ट लागलेला आहे, शेकडो मुलं असतील ज्यांना खूप चांगले मार्क्स मिळाले, पण हजारो मुलं आहेत ज्यांना खूप वाईट मार्क्स मिळालेले आहेत. आपण त्या शेकडो मध्ये असलो पाहिजे. 5% सुद्धा मुलं नाहीयेत की ज्यांना खूप चांगले स्कोर्स आलेली आहेत. नॉट इव्हन 5% एंटायर बोर्ड मध्ये. पण ती 5% मुलं आहेत की ज्यांना खूप चांगले स्कोर्स आले. अगदी मॅथ्स मध्ये 100 असतील, फिजिक्स मध्ये 100 असतील, केमिस्ट्री मध्ये सुद्धा असतील. तुम्हाला त्या लोकांसारखं काम करायचं आणि त्याच्यासाठी फार विशेष काही करावं लागत नाही. जसं तुम्हाला म्हटलं, स्टडी म्हणजे टीचिंग आणि सेल्फ स्टडी हे सगळं तुम्हाला 10th ला होतं. हे माहितीये का रे? सीबीएसई मध्ये तर डेफिनेटली होतं. पण आता आपण जर म्हटलं की नाही आम्ही एसएससी चे आहोत, परंतु आपल्याला एंट्रन्स तर सेम द्यायची. दॅट्स वाय यू हॅव टू स्टडी इन डिटेल. अनिकेत मोरे झोपलाय का? अनिकेत मोरे ज्यांना झोपायचं त्यांनी नकानं जॉईन करू बाळा. हजारो मुलं, शेकडो मुलं आहेत ज्यांना माझ्याकडे क्लास हवा आहे. आणि आता याच्यामध्ये मेजॉरिटी मुलं बघा, जवळजवळ 90 पर्यंत पोहोचला होता नंबर. त्याच्यातलं फक्त 2-3च लोक आहेत की जी इझी आहेत. 85 स्टुडंट्स आर सिन्सियर. एखाद्याला जर सपोज नेटवर्क प्रॉब्लेम येत असेल तर आय कॅन अंडरस्टँड. ते मी समजू शकतो. हे लेक्चर रेकॉर्ड होणार आहे, ते दिल्या जाणार आहे. ओके. So now tomorrow I will be telling you how the questions are framed. How the questions are framed and how we can solve number of objectives on this. हे मी तुम्हाला सांग